A Voith Schneider propeller, or VSP, unlike conventional propellers, is a vertically mounted and rotating disc with blades that can be adjusted to change the direction of thrust. The VSP is powerful enough for the tug to assist a larger vessel. The secret of adjusting the direction of thrust is that each blade can change its angle when rotating. Let's take a look at the mechanism of this propeller. These are propeller blades. Kinematics, the linkages that control each blade's angle. Control rod moves the kinematics. Hydraulic cylinders push or pull the control rod to set blade angles. All of these are inside the rotor casing, which is driven by power from the main engine. The engine turns a bevel gear. The bevel gear drives a sleeve connected to the rotor casing. The whole rotor casing and the blades inside rotate together. This combination of constant rotation plus changing blade angles is what gives the VSP its maneuverability. Propeller housing covers the upper parts of the system. Let's look at the propellers from the top view in a slow motion. All blades move along a circular path. At this moment, we are seeing the blades are set at zero thrust, which means the boat is not moving. When the blades start changing the angle, it can control the direction of water inflow and water downwash. Therefore, it can indicate the thrust direction. For example, the boat is moving ahead in this case. Changing the angle again will have the boat moving astern. To control the tug's direction and towing power, the captain uses three main controls inside the wheelhouse: the steering wheel, the driving pitch levers, and the engine RPM controls. Let's zoom out to see how these work together. The driving pitch levers adjust the angle of the blades, which changes how much water flows in and out. The steering wheel changes the circular direction of those angled blades, deciding the direction of water flow. The RPM controls set how fast the propellers spin. By combining these three controls, the captain can steer the tug in any direction with precision. This tug model uses two medium-speed marine diesel engines. Each is a 4-stroke engine with 8 inline cylinders. They typically operated at 800 RPM, producing around 2700 kilowatts or 3700 horsepower. The engine can be built to rotate either clockwise or counterclockwise. In a dual engine setup, each engine can spin in the opposite direction to the other. The crankshaft is the first component to generate torque, transferring it toward the propeller. Between the crankshaft and the propeller, there are two important devices: an elastic coupling and a fluid coupling. The elastic coupling connects two shafts. It absorbs vibrations and reduces stress on both shafts. The double-circuit fluid coupling, which acts like a clutch, it can either engage or disengage the rotation between the driving and driven shafts. The coupling has two sides, the input side with two impellers that deliver torque, and the output side with two runners that receive torque. Inside, the coupling is filled with oil or hydraulic fluid. When the impellers rotate, the blades inside drive the fluid and create a vortex flow, which spins the runners. Since the impellers and runners don't make physical contact, wear and tear on components is reduced. When fluid is withdrawn, the runners stop rotating, cutting off power to the propeller. Fully electric Voith Schneider propeller has already been developed and applied in ferries, but for tugboats, the time is coming. Soon, one will enter service. On one end of the engine, a fire pump can be connected to take advantage of the crankshaft's rotation. Between the engine and the pump is a dry disc pack clutch. When engaged, it transfers power to spin the fire pump. Water is then drawn from the sea chest and sent at high pressure to the fire monitors on deck. During a firefighting mission, up to 30% of the power normally going to the Voith Schneider propellers is diverted to the fire pump. This sharing of the power slightly reduces propulsion but allows the tug to fight fires effectively. Fire pumps can also be installed on the opposite end of the engine, and the free end can be adapted for other equipment. Some tugs also carry separate diesel generator sets or gensets, which produce electricity at any time without relying on the main engine. A tugboat's hull is shaped like a deep bowl, keeping much of it submerged for excellent stability. At the stern of the tug, you'll notice a fixed fin called a skeg. It doesn't steer like a rudder. Instead, it gives the tug stability in the water. Around the tug are inflatable rubber fenders, which act as cushions to protect both of the tug and the ship's assist during close contact. The hull is made of thick steel with extra strong frames. The bow is especially tough with reinforced steel to tow and to take hits when working alongside giant ships. On top is a wheelhouse. This spot gives captain and crew a clear visibility of everything around the boat. Beneath the wheelhouse is the crew accommodation. It's a compact but functional home for the crew during their time at sea. VSP tugs assist bigger ships entering a narrow water channels, docking, and departing. Thank you for watching. If you know anything more about this topic, please leave a comment below. My name is Lucius. I'll see you in the next video.